I welcome all of you on the platform of YourPedia Education. This is the dedicated platform for all the students who are aspiring to pursue career in higher education and research. As you know, YourPedia got opportunity to go for the academic profiling of very prestigious IIT, that is IIT Gandhinagar. We as a team could go there and interact with the professors, students and other staff of IIT Gandhinagar. We could visit various labs, we could get the opportunity to interact with the professors related to their research areas, and those interactions now we are showing to all of you, those who are interested to work under such learned mentors. Today's video is related to one such interaction of one professor who is very knowledgeable and is doing marvelous work in some of the latest research areas in the domain of electrical engineering. So today in my interaction I am going to interact with Professor Arup Lal Chakravarti, and he is doing marvelous work in the research areas which are tunable diode laser spectroscopy and optical, physical and chemical sensing. I could visit his lab, so that video also you see. Such interactions and such informations are very important for those students who are planning to pursue the career in research, or through this particular master's course they want to check out various career opportunities for them. During the interaction, normally I am asking the professors that what do they see in their prospective students. If you want to join under Professor Chakravarti for MS or PhD, then what Professor Arup will see in you. So how you can think that okay, I am the right candidate for Professor Arup. So what are the requirements? Listen to that carefully. When Professor Arup tells that yes, if you want to join under me, under my guidance, under my mentorship, this is what you should have. Listen to that part very carefully. Second, you should also listen to what research areas Professor Arup is working. It may match with your interest. And you should pursue research in the domain where you find some kind of industrial applications. So I am going to ask Professor Arup what are the industrial applications of the domain of research in which he is. And the second part of Professor Arup will be related to his research lab where he is doing wonderful work, followed by some of the students of his own lab with whom I have interacted, some of his students who are already faculty and they are in industries now with whom I have interacted. So there will be sequel of videos of Professor Arup and his lab. So let me tell you some of the research areas of research papers, recent papers of Professor Arup. These all are available on the website of IIT Gandhinagar. You can see these research papers, and if you find that yes, these match your domain of interest and you want to work under Professor Arup, you can go through these papers, have some kind of idea, and in your research proposal you can write these things in research proposal, and maybe you can approach Professor Arup also. So let's listen to my conversation with Professor Arup. I am very sure you will get a lot of good ideas through this interaction. Thanks a lot, Professor Arup, for giving me this opportunity to first visit your lab and now have interaction with you. Thanks a lot.
You're very welcome to our lab.
Okay. So Professor Arup, I was just visiting your lab and some of the very good facilities exist there, and I could interact with the PhD scholars also, and that now I get opportunity to interact with you. So I have some interaction points, Professor, but before that I would like to I request you to tell something about your academic background, academic journey, because there are so many viewers are the students who would like in future to work with you under your guidance. So please, your academic journey, very briefly.
So I grew up in Calcutta.
Okay.
My schooling was in Calcutta, and then I did my undergraduate in electronics and communications engineering, MTech, from the University of Kalyani, West Bengal. The college was a private college in Calcutta, very new. And after doing my BTech, I joined the Department of Atomic Energy as a research center in Indore, Raja Ramanna Center for Advanced Technology. I was working in the lasers division there. I worked there for 7 years, developing laser-based sensors. And then the urge to get into teaching was very strong for me. It runs in the family. So I quit and I went to Glasgow, Scotland, to do a PhD. And I returned in 2010 and joined IIT Gandhinagar.
So you are with IIT Gandhinagar from the very beginning, because as per my knowledge it was started in 2008.
2009
Okay, nice.
And I joined in 2010, May of 2010. Yeah, one of the early faculty members.
Okay. So, Professor, that gives me opportunity to ask you another question here. Like, when you joined IIT Gandhinagar as a new IIT, you must have come across many challenges, but at the same time, there is opportunity also.
Yes.
So, being professor in a new IIT, but with a difference. So, what challenges and what opportunities did you face?
So, interestingly, this was the third time when I was joining a new lab or a new institute.
Okay.
My undergraduate college, I was the first batch. So again, it was new.
Okay.
In our GATE, I joined a lab that was completely new. So we had a building, nothing else.
Okay.
So it wasn't a totally unfamiliar setting.
Okay.
Come and join a new IIT.
Okay.
We don't have a campus, we
Okay.
don't have labs.
Okay.
So it wasn't completely unfamiliar.
Okay.
It was definitely challenging.
Okay.
So to set up a lab from scratch, buy every piece of equipment, and there's teaching going on in parallel. There's so many other institute activities to participate in. It was very challenging. But at the same time, the freedom to develop things on your own as per your judgment and the way you envision it, that was very attractive for me because I would not have been happy in a place where restrictions are placed on me. I'm not that kind of a person. So a bit of uncertainty was not unnerving. I was lucky to have students who were very hardworking in the beginning, now as well. So that definitely helped. So on the whole, it was challenging, but not something that I felt where I was out of my.
You had already the experience of similar situation. Great. So, Professor Arup, now I come to your research areas, research domains. So, what I understand is like your domain of these photonics and sensors. This looks like quite interdisciplinary, and that I came to know through when I interacted with your students. Electronics, biomedical, electrical background, maybe mechanical engineering and physics later on. So what kind of research areas you are working presently, and what are the research domains which are handling as of now?
We mainly work with lasers and applications of lasers in sensing. There are two kinds of sensing that one can do. One is sensing of physical changes, deformations, vibrations, displacement, temperature, and the other could be chemical changes. So there's a chemical reaction that's going on, producing some kind of a byproduct. Typically, we work with gas phase. You're either trying to measure a leakage of a gas, or you're trying to measure a byproduct or product or a byproduct of a chemical change. So physical and chemical sensing is our domain. Now, we have to ask, where are these physical and chemical changes taking place? That is where the different domains come. So you've spoken with Chandan, who was working on developing a glove that will be able to tell you the bending of the joints of the fingers. Now that is a biomechanics, biomedical domain. That application is, his PhD has shown that it can be effectively addressed by using fiber Bragg gratings through which laser light passes. So that's a biomedical application of physical sensing. Likewise, we're working with an industrial gas sensing applications. Like we executed a project with a DRDO lab, Bangalore, Deatiled. They wanted to measure oxygen leakage in their helicopters. So we did a project together where we developed a system, prototyped it, and gave it to them. So that's an oxygen leakage from a oxygen generating system in a helicopter. Likewise, you could have different kind of industrial applications where either you're detecting leaks or you're detecting the products. So the footprint of the application can be very wide, and we work in partnership with someone else. So often you have a mechanical engineering background, so combustion is fuel cells. These are mechanical engineering domains. So I've partnered with the mechanical engineering faculty here who is working on fuel cells, where our kind of sensing would be useful for him to analyze whether his system is working well or not, and to optimize that system. So that's the kind of That's the way we approach the research. It's highly applied in nature.
That's true. So Professor, my next question is something which you have already answered, but still I want to ask you and take your view on that. It is said that research should not sprout from research papers. It should actually come from real world problems. So when I was visiting your lab, I felt that way. I mean, the kind of problems you are identifying, they're coming from the real world problems, and you are trying to find solution to that. I want your further view on that.
Well, research is definitely of two types. One is an applied research that can be, the knowledge can be applied immediately. The other kind is a basic research done. And both have their merits, and both are valuable. The kind of research I have been doing, I'm trained to do, is more of the applied kind. Although there are a few basic research questions that we've started to ask. But yes, you're right that we try to place our research activities in the right context. So we know, for instance, that there are a large number of sensing applications in India that currently are not addressed to the extent that they can be addressed. So vibrations in structures, bridges, dams, big and large structures. There's a huge opportunity, and the field of sensing in India, unfortunately, I don't think it has, not just me, this is a general feeling, that it has not been explored to the extent it should have been. So we're trying to address that gap. And there are some leading groups in India who are also pursuing the same agenda, that the sensors that we build in the lab must be able to go out and give you reliable measurements out in the field. And those measurements then can feed into either theoretical models or policy decisions, things like that.
So Professor Arup, now I come to next interaction point, which is related to the lab itself. You know, when we compare IIT Gandhinagar, relatively new IIT with old setups, you mentioned about the labs, DRDO labs, or other research facilities, and then we have old IITs, many institutes, many other institutes also. So where do we stand as far as the facilities we have developed in our lab, and what is your vision for developing such facilities in future?
The kind of equipment that we have in our lab is not large.
Okay.
These are small devices because we essentially work with semiconductor lasers.
Okay.
Now, semiconductors immediately gives us tells us that things are going to be small. So the lasers that you saw are all very small. They require very little amount of current. So the footprint is very small, but they are extremely powerful. And they are powerful because their emission wavelength can be precisely tuned. And so this gives rise to the field of tunable diode laser spectroscopy. Now this is a field that is still very new in India. When I joined in 2010, there was probably just one other lab in India who was involved in this kind of research. And even today, there are only very, very few places where this technology is pursued. So, in that sense, we have a unique position in the Indian sensing landscape. But our lab is the only one that does this kind of tunable diode laser spectroscopy, photoacoustic spectroscopy, these kind of applications. And going forward, our vision would be to engage more deeply with industry and pursue these industrial applications. And these are all going to be interdisciplinary.
So, but do we have industries in the nearby places of IIT Gandhinagar, or location becomes handicap for you?
Not really, because Gujarat has a huge amount of industries and a variety of industries. So you can have petrochemicals, you have agriculture, you can have other different types of industries, chemicals, pharmaceuticals, and all of them have some kind of either a carbon footprint that's going up in the air, or they are pumping effluents into the water bodies. So there is a huge amount of sensing that needs to be done
Yes.
to understand what these industries are doing to the environment. So there's a huge scope for this kind of work.
So, Professor, now I come to next part, which is something which is very close to what I am doing. That is entrepreneurship. I could interact with one of your students, Chandan, and I am happy that he's into entrepreneurship, and now he's, I think, 1 year in entrepreneurship. I could discuss in detail with him, and he was explaining like some gloves he has made for these people who are paralytic or something like that. And that work looks like good. I mean, he's doing good, and IIT Gandhinagar has provided him some kind of ecosystem where, in the initial years of his entrepreneurship, he can pursue his that venture. So that is something which is good. I think institutes are the breeding ground for entrepreneurs. I want to take your view on this. In this particular matter, I'd like to ask you two things. Number one, what kind of facilities IIT Gandhinagar provides for this kind of entrepreneurship opportunities for, especially for students in very specific domains, like BTech people can get into various generic domains, but when we come to PhD, you have very limited domain in which you can pursue your entrepreneurship. So what facilities IIT Gandhinagar is providing? And my second part of this question will be, what are the various entrepreneurial opportunities existing related to your field of research?
To answer your first question, I think the entrepreneurial activities are still very new in IIT because the first few batches of PhD students have started to come up.
Yes.
And entrepreneurship is not everyone's cup of tea.
Yes.
So with Chandan, we had the experience, we've had a very positive experience. The support that we've got from the entrepreneurship cell that's part of the R&D setup has been extremely good. Mr. Anand Pandey, in particular, he's been guiding us through the patenting process, connecting Chandan with various funding agencies, obtaining feedback about the kind of work he's doing to calibrate the kind of work. So that has been a very helpful input. The other thing is that the interdisciplinary nature of research in IIT Gandhinagar, that has been very helpful. It's very easy to go into someone else's lab and do a bit of work for 6 months, 8 months. We don't have those hard walls. You don't have to obtain approvals and things like that. So that kind of a flexible setup, porous boundaries, that has helped. Some colleagues have been very, very helpful, extending their research, extending their know-how. You have the Tinkerer's lab right opposite. These kind of things have been very helpful. So, yeah, and in Chandan's case, it helped that most of the equipment that he needed was available in our lab. It's not very large. It's small pieces. So that was fairly easy. And your second question was the
Entrepreneurial opportunities in your
yes.
domain of research.
Yeah. So again, this work, as I was saying, because there's so much of industrial work that can be done, there is the opportunity to spin off a company that has a portfolio of sensing. But we need students of that kind who will take charge of that. For me as a faculty member to concentrate on that is going to be difficult. I don't have that bandwidth. But someone who has the training in doing this kind of photonic sensing and has the desire, the risk-taking ability and the determination to pursue it will find a huge amount of support because let's not forget that the current market, the worldwide market for photonic sensors is going to touch 4.5 billion US dollars by 2025. That's the projection. So it's a seriously big market. If some of the Indian PhDs and MTechs realized this, I'm sure we would have more such serious startups. Some of the IITs have done extremely well. IIT Madras comes to mind. I know people over there. They have been working very aggressively on this front. But I think there's a lot of opportunity for someone sitting here to do it. Because Gujarat is heavily industrialized.
Yes, yes. And there's an ecosystem of entrepreneurship in Gujarat.
There's a need for the sensing and there's a entrepreneurship spirit. So if these two can be put together, lots of things can be done here.
Okay. So this question which I'm going to ask you now, just popped up. So I'm not prepared for this question and just came to my mind. I want to ask you, Professor. Now this e-vehicle market is coming up, in a huge way. You're talking about the sensors and all these things, and I've heard those things in there also. Is there any correlation of your work with that industry?
I'm sure there is, but I can't put my finger on it right now because what I can say though is that we've seen these self-drive cars,
Yes.
automotive,
Yes.
what do they call it? The self-drive cars.
Yes, yes.
So you'll see these cars moving around with something revolving on top.
Okay.
And they can reconstruct the scenery
Okay.
around them.
Okay.
They use a technology called LiDAR.
Okay.
So that's light detection and ranging. So it's the same thing as a radar,
Okay.
but except that you're sending out light pulses
Mhm.
very rapidly,
Mhm.
360 degrees around you.
Mhm.
And from the reflection,
Mhm.
you are recreating the scene.
Mhm.
And then computer vision and pattern recognition and all that comes in.
Mhm.
But the basic creation of the scene
Mhm.
is essentially photonics.
Okay.
So it's related, but I'm not sure if electric vehicles is a direct match.
Okay.
There might be small components over there, but self-drive cars, drones, collision avoidance, those kind of things, they rely very much on LiDAR.
Now, Professor, I come to our last interaction point of this conversation, and that is related to the students. When students, there are thousands of students who aspire to be in institutes like IIT Gandhinagar and work under professors like you who are knowledgeable in their domain and they want to work in the state-of-art facilities like your lab. Now, I want to ask you very straight, what do you see in your prospective students when somebody approaches you for his master's or PhD or maybe postdoc? What comes to your mind and what do you want to see in him so that whosoever is listening to you, at least he can groom himself for working under you someday?
Him or her.
Or her, yeah.
You have seen most of
There
our
are two
students
girls,
are.
yeah. So that is
girls, yeah.
more inclined towards women.
Yes. I think, see, the kind of work we do is interdisciplinary in nature and you can approach it from different directions. So, what I look for is a couple of things. One of it is creativity.
Okay.
Is a student interested in creative hobbies or creative ways of thinking, or is a student only going to go by the book? Okay. I don't think that's a very good. It's not a good thing. Solid fundamentals is very important. We're not too worried. Typically, in our interviews, we're not too worried if a student doesn't remember a formula. But if a student doesn't know whether a capacitor, for instance, is a linear device or not, then we're very worried.
Okay.
So if we see conceptually weak students, that becomes a problem. I also, in particular myself, I look for students who are willing to learn by themselves. Not everything can be taught through lectures, but does the student have that determination? So sometimes that can be gauged. And typically within a few months, even 6 months, you can gauge whether the student has that inherent desire to learn, correct that. So these traits are very important for me. More than whether you've scored 9 out of 10 or 80% number of A's, that's less important. Am I willing to cross a boundary and get into a field that I don't know much about, but am I willing to work hard? That's very important. And is this person in general an interesting person?
Okay.
Because in a lab you need to work with 5, 6 other people. You need to go and speak with someone else.
Yes.
And typically we like to interact with people who are interesting.
Yes.
And interesting people do interesting things. A hobby often feeds into the work that I'm doing here. So that's the creativity and that interesting part that I'm talking about. So these kind of students enjoy the kind of interdisciplinary and open-ended kind of work in our lab. And research is basically open-ended. So people who are anxious to have a rule book or a manual, it's not that much fun.
So basically he should have good concepts, basic concepts. Maybe he's not remembering the formula, but he should have zeal, he should have passion, he should have interest to do what he's trying to do, and he should be a little creative and get along with others.
Yeah, willing to learn new things.
Great, Professor. So we come to an end of this wonderful session. Let me thank you once again that you gave me opportunity for such elaborate interaction with you and showed your lab. Really thanks a lot once again, Professor.
I'm very glad you thought of coming here. I hope some of this discussion will be useful to your students.
I'm sure it will.